Okay, great. We will create two variables that measure the size of our inputs and outputs. The input size is 2, as there are two input variables, the x's and the z's we saw earlier, and the output size is 1, as there is only one output y. Okay, these two lines of code assign the values 2 and 1 to the variables input size and output size. That's programming you are familiar with, nothing new so far. Time for the peculiar TensorFlow logic. Each object we will create using the TensorFlow library would do nothing unless explicitly told to. It would rather describe the logic of the machine learning algorithm, but won't assign values or execute anything. Remember that, as it is crucial. Time to define our first TensorFlow object, the placeholder. Let's see the line of code that allows us to do that. Inputs equals tf.placeholder of tf.float32, comma, square brackets, none, input size. The placeholder is where we feed the data. The data contained in our dataset would go into a placeholder. Naturally, we feed both inputs and targets. Let's include the code for the targets. The data in the NPZ file contained exactly the inputs and the targets. We will use the NPZ to feed data into the model through the placeholders. The float32 indicates the type of data we want. 32 bits float precision is sufficient for most calculations. Finally, we have the dimensions of the two placeholders. The input's dimensions are none by input size. The input size is the number of input variables we have. The none you see here doesn't mean the data has no dimension. Instead, it means we need not specify it. That's useful for us, lazy users. We need not know the number of observations or keep track of it. TensorFlow does that for us. We are only interested in the number of input variables. As you can see, this isn't much different from our linear model. The dimensions we are working with are n by k, where n is the number of observations and k is the number of variables. Okay. Similarly, the size of the targets is none by the output size. That's natural, since outputs and targets have the same shape. Remember, nothing has happened yet. We have instructed the algorithm how we will feed data, but no data has been fed. Alright. The next thing we would like to do is define the weights and biases. They are declared using the other basic TensorFlow object, variable. Variables preserve their value across iterations, while placeholders don't. Allow me to elaborate, please. Let's say we have two inputs, A and B, and two targets, C and D. A goes into the input's placeholder. Through the weights and biases, we can obtain an output. Then, we compare the output with the target C. Depending on the comparison, we'll vary the weights and biases and continue with the next iteration. Then B goes into the input's placeholder. Through the updated weights and biases, we calculate the new output, which will then be compared to the second target, D. Then, we'll adjust the weights and biases once again. Okay, A and B came and went away. We fed them to the model, got the best out of them, and we no longer need them. The weights and biases, however, were preserved throughout the iterations we performed. More precisely, we updated them and kept their updated version using the information provided by A and B. This is the same process we carried out before, but we used a different wording to describe it. We feed the data in the placeholders and vary the variables. Simple as that. Let's define the variables. The proper method is tf.variable. The expression you see within the brackets show us how the variables will be initialized. We will use the random uniform method to be consistent with the minimal example shown earlier. This is something we'll discuss in more detail later in the course. Notice we have the same shapes as the one we had in our framework. We've prepared the inputs, weights, biases, and targets. We still need the outputs. The outputs of our model are the product of the linear combination of the inputs times the weights plus the biases. The proper syntax in TensorFlow is outputs equals tf.mapMul of inputs and weights plus the biases. MapMul relates to the same concept as the dot product, but generalized for tensors. In the brackets, we plug in what we want to multiply. So this is our linear model, right? Before we can continue, I would like to ask you a question. What will happen if I run the code? Nothing! Our model will do nothing. It doesn't initialize the weights or biases, nor it plugs in any values. It certainly doesn't calculate any outputs. It lays the logic through which this will happen later. That's what TensorFlow logic is all about. Okay, now that we have placeholders, variables, and mathematical operations all set up, we can pause here. In our next lesson, we will choose a loss function and an optimization method for our model. Thanks for watching.